Okay, thanks for the introduction. Hi everyone, hope you all are well. Now, where do I start? I was asked a few weeks ago if I'd like to present during Wi-Fi Design Day, and before I could even answer, my sales counterpart, the regional sales manager, kindly volunteered me. I was actually supposed to be on holiday today, but I agreed, I cancelled my holiday. I didn't really have anything planned as such, just packing and preparing for moving house, as I've just mentioned, hence all the boxes behind me. So here I am. The next issue I had was to pick a topic. Now, this was a challenge in itself, trying to come up with something that wouldn't overlap, be a sales pitch, or clash with the other speakers. I eventually settled on mesh Wi-Fi and how 802.11ay can be used to improve some outdoor deployments. I'm not going to sit here today. I'm not going to tell you how you should set up mesh deployments. I'm not going to tell you the do's and don'ts. What I want to do is I want to give you a brief insight and potentially get you thinking. So to start, what is mesh Wi-Fi and why is it used? So wireless mesh, mesh Wi-Fi, wireless LAN mesh, whatever you call it, going back to what Peter said this morning, whatever your language is, it is the ability to wirelessly connect mesh capable access points so that they can communicate with each other to create a wireless infrastructure to allow clients such as phones, laptops, tablets, etc., to connect to the network. Most mesh networks will allow for self-healing, rerouting of traffic if the design and the setup allows it. Mesh Wi-Fi is typically used when it's difficult to cable or if it's cost prohibitive. Let's say you have a room that needs coverage and it's just over the permitted cable run. And you just need to allow one or two devices to connect. It's easier to just use mesh than it is to run a fiber or to put in another switch. You can simply just use the functionality of creating a mesh link. Mesh can also be used as a multiple hop. Now, I'll put my hand up here. This is where my animosity of mesh Wi-Fi comes into play. And as we go on, you'll probably understand why. But before I carry on and get any further, let's just have a look at some use cases. This isn't all the use cases, but it should encompass enough. Residential, this to me is probably the strongest use case and the one that I see the most. Over the years, as time has gone on, roll back to when I was in school, you might have had a family PC and it was usually connected directly to the router via a cable, network cable, or you had a modem and it'd be plugged straight into the phone line if you had dial-up. But as time has moved on, wireless devices have started to appear. This is great, right? Because it's actually allowed us to be here talking today. But as I said, as more devices start becoming wireless enabled, tablets, laptops, smart devices, Google Hub, Amazon Echoes, Samsung fridges. Also, you've got the moody teens that are in the bedrooms playing on consoles, streaming. The standard home-based wireless router might not give you the signal and connection rates that you need everywhere. This is where mesh Wi-Fi comes into play, because for the majority of people, it will do what it needs them to do. There's plenty of mesh wireless access points there on the market right now, consumer grade stuff, the BT Disc, Amazon Heroes, Google Mesh. Then you can get into some of the more enterprise stuff. Even Cambium Networks have got some. There's plenty out there, and they'll all offer and ensure adequate coverage throughout a family home. Looking at the enterprise, some enterprise networks, as mentioned previously, might use mesh due to costs for a particular room. But to be fair, as time has moved on, and with indoor enterprise mesh, I see less need for it now. Maybe it's because everyone is designing against using mesh in these environments due to the advancements in technology and how technology is used now. but I still see the request asked of me every now and again, and I do shudder. Outdoor enterprise need for mesh I see occasionally, and it's mainly when a school, a college, a university needs coverage in a particular area, on a field, a running track, a car park. When we look at externally, so shopping villages, high streets, pop-up events, small campsites, this is something that I see that's raised more often than not, because what they want to do is they want to provide coverage to get people connected. So far, I've actually made mesh sound good, right? To allow you to extend coverage to allow clients to connect by simply adding an AP. So what's the catch and why doesn't everyone do it? So let's talk about performance and density briefly. As usual, as density increases or the number of connections of clients increase, the effective client perception of performance decreases. Now that's just a general statement for an access point, but for mesh it's actually compounded. The first AP is the only AP that's physically connected to the LAN. The next AP is effectively acting as a client in its own right, and any clients connecting to that second AP in the hop are sharing the connection to the first AP at the speed of the wireless link, which even if you have a certain connection rate, your throughput, for argument's sake, and don't quote me on this, is about, let's say, 50% of that connection rate. There's a lot of factors to take into account, but the argument still stands. So rather than having a 1 gig connection like the first AP, you may only have a 100 meg theoretical connection, and that 100 meg is going to be shared with all the clients on that AP. Then we look at multi-hop, and as you get further down, the more hops you add in, the more devices you're sharing over those hops. So you then get an issue of contention. But as time has gone on with the evolutions of Wi-Fi and now with 802.11ax, 802.11ax actually helps with this, but is it enough? For some deployments, yes. For others, probably not. So how can we improve those deployments? Well, simply just plug a cable into the access point and you're sorted. But for the areas such as the outdoor city centre deployments, campsites, pop-up events, this is where I'd look into using FWA. FWA is fixed wireless access. Fixed wireless access, effectively using a wireless link for the backhaul communication. There are multiple ways, products, bands that you can use, but what I want to talk to you about is 60 gigahertz and how and why we can use 60 gigahertz to help with some outdoor wireless deployments. So what is 60 gigahertz? It operates from 57 to 70 gig. It's divided into 6 channels with a channel size of 2.16 gigahertz, giving 6 channels to use. In Europe, we have 4 channels to use, channels 1, 2, 3, and 4. It offers a very low latency. It has symmetrical throughput, so effectively it's got the same upload speed and download. And the throughput speed you could be looking at are up to 3.8 gig upload and 3.8 gig download. And then if you have a look at using channel bonding, you could actually see speeds of 7.5 gig upload and download, giving you a nice backhaul link to work with. 60 gigahertz use appeared roughly in 2016 with 802.11ad, but what I'm going to mainly talk to you about today is 802.11ay, which is the newest standard, specifically Telegraph, which is Facebook connectivity technology. Yes, there are downsides, but like anything, if designed correctly, you should be able to overcome them. 60 gigahertz is affected by oxygen and rain, meaning you're going to get a shorter range. You may need multiple hops if you want to cover a larger area, and you do need line of sight. So I mentioned 60 gigahertz started with 802.11ad, but what's the differences between .11ad and AY, and what is special and why now? So 11AY is totally different standard, much like .11n, is different to .11ax. .11ay offers better performance, deployment options, and efficiency factors from the amount of CPUs per sector, higher throughput, and the ability to use TDMA, which is time division multiple access, along with TDD, which stands for time division duplex, as opposed to the CSMA with CA, which is carrier sense multiple access with collision avoidance. All of the improvements from AD to AY can be leveraged to provide a robust, high-performing backhaul for external deployments. So by using TDD synchronization, which allows us to control when we send and receive, each radio can be assigned a specific polarity, an odd polarity and an even polarity. So with each TDD frame, the odds will send when the evens receive and vice versa. So this allows us, by using TDMA TDD frame structure, to reduce interference, and we can also achieve a single channel operation. 802.11ay with terograph configurations support point-to-point, point-to-multipoint, and mesh. If we ever think about those outdoor deployments that you may have been asked to deploy, how many of them are actually set up in a true mesh configuration? Are some of them set up in a point-to-point fashion? Are some of them set up just for a point-to-point scenario? This brings me back to the outdoor deployment. You can use 60 gigahertz for your backhaul and connect client serving access points onto your 60 gig solution. As mentioned, in many ways to achieve the requirements you have, so the mesh that then can connect some additional client nodes to the distribution node, and then put more APs connected to those client nodes. By doing this, you can actually maintain a high-performing backhaul network at line or greater than line-like speeds. Yes, this solution might have a certain cost implications as it's additional kit, but it also might allow you to provide what the end users actually need to overcome the obstacles of cabling and potentially performance issues. I started this presentation by saying I'm not going to tell you how you should set up mesh deployments or the do's and don'ts. What I want to do is give you a brief insight and potentially get you thinking. And I hope I've managed to do that. Thank you for your time and thank you for listening.